listen, if you have questions about any particular one, we can do it after class. We can do it after lab tonight. Or if you didn't come, hold on, everybody, listen. Everybody stay with me. Ben, give me a minute. So you can always look over this before class. Now, if you come next Tuesday and say, can I see my test? I'm not going to have it unless you warn me that you're coming. I'm not carrying this big stack every time I come. So if you want to look at your test, you have to text me before you come and say, I'd like to go over the test, so I'll bring your test. Right? Don't just show up and think I don't have your test. I want to go over a couple things and give you some hope. I think that if you're in the 70s, that your goal realistically should be an A for this class as a your final grade. I'm not blowing smoke. I'm telling you that the average on this first exam, I'm getting goosebumps just telling you, the average on the first exam is usually like a 60, sometimes like 50s. You guys had a 72 average. So that means that the exams don't get easier. They're the same format, the same length, but most people either say, oh, I didn't study enough, or as many days in a row as I should have, or you make adjustments, and you do better on the next one. And I told you by the third exam, the average is in the 80s. So I don't even know what that means for this class, maybe upper 80s. So there were a couple things in the written that I want to go over. I would say 90% of the questions were questions that I gave you in class. I told you this was going to be on it. So, for example, if you missed any part of the table, you just have to say, what in the world? What's going on? You can't miss questions that I tell you are on the exam. And then I give you some questions to think about, right? Like the question dealing with seawater. That's just really a hypotonic question. And then there was another table dealing with diffusion, osmosis, and filtration. And that was something that we also drew on the board. So remember that if anything goes on the board, it's fair game. If there's a video about telomeres, then you should jot some things down about telomeres. And it's hot in here. I am calling complaint. Okay, so congratulations on this. If you got below a 50%, stay with me. I don't think you're going to end up with an A in here, even if you ace everything. So if you got below a 50, I think A is not likely. So if you got even worse than a 50, and there were about 4 or 5 of you, then you have to start saying, no, one, I'm just being real, I'm not being mean. I'm going to say, listen, am I going to go through this entire class and get a grade that's not good enough for my major and have to retake it? So some of you are in crazy majors that I don't know what you need in order to move on. I will say if you're nursing, you probably shouldn't get lower than a B. Okay? So if you are below a 50% on this test, I think it's going to take some serious work to get into the B range, but probably your goal would be a C. And is that good enough? Okay? If you got a really bad grade, you might say, it might still be early enough to get my money back and try again in the fall. That's awful to say after the first test. But if your score is really low, it's hard to mathematically climb out of that hole. But the good news is the average was 72, and most of you are in line to do really, really well. So remember, next week is our first lab practical. I've always called the lab practicals the curve of the class, because most people get A's and B's on those. So I wouldn't really go into panic mode and really think about withdrawing or whatever until after you see how you do on the lab test. If you get an A or B on the lab test, your grade's going to jump up and you might feel like, okay, I can do this. But I love the fact that I had about 12 people come in before class today, and, you know, some of them were kind of mad, you know, and I said, well, wait a minute, you got a 75. That is really good for the first test, you know, and people were unhappy with it. I love that, you know. You have standards. You want to make sure that you know, achieve really well. And I think that, you know, this is why this class will probably go down as one of my highest scoring classes, because it seems like you guys are really driven. So for those of you who didn't do as well as you want, it's not the end of the world. Just make some adjustments, do better on exam 2, and then by exam 3, if you're not into the B range, then you probably should kind of think about, you know, what are my options. All right, so please turn the exam over and pass it towards the edges of the room. I'll collect them.
Which means they had more water than the outside.
Yeah, so this, by osmosis, water's moving from high to low, so water's moving out of the cremate. If they lysis, that means cells are coming in, there's less water inside the cell. The cell is hypertonic, right, because it has more solutes.
Right, so the fish one was in hypo.
Which one, the CSI fish?
She would have less solids because the water.
It died by cremation.
Yeah.
Okay, everybody, so today we get to start our new topic. One of the questions that I had before class was, hey, are your exams comprehensive? Do I have to study all that chemistry stuff for test 2? The answer is, I'd say maybe one question will be over the previous material, maybe one. So I'm going to say 98% of the next test, test 2, will begin with this information today and go till our last lecture before test 2. There might be one question or two that deal with something that we talked about in the past that I think I would probably have mentioned a few times, so I'm not going to throw something out randomly, so usually that's not a problem. Okay, so today we're going to talk about histology, which you guys are good. You guys should be good. You have all those pictures of all those slides on your phone. That's what we did, 2 weeks ago in lab, in that crazy lab where we tried to do all this work in one lab. So we're going to talk about histology, going to go over some things, talk about some details that we kind of breezed over in lab. And then at the end of class, we're going to talk a little bit about some issues associated with the tissues. And this will be our last lecture on a non-organ. So it's kind of exciting because next Tuesday we start skin. And you might say, oh, finally, I get to talk about or learn about something, you know, like a system, you know. So we'll go from skin into the world of bones, and then we'll stop at bones for test 2. Okay, everybody good? Everybody dripping sweat like I am? All right, so one of the things that comes up sometimes when we study histology is, you know, why do we care, you know? But I think some of you might even go into an occupation where you're working in the lab. Because all of us have been in a hospital where we had a sample taken and they sent it off to the lab. Or you had your blood taken during your physical, or because you're sick and the antibiotics aren't working, let's do a blood sample. And where does that blood sample go? It goes off to the lab. When my son was getting his brain biopsy, his surgery was like 4 hours. But he said the actual surgery was only 2 hours because there was an hour of downtime where they sent a piece of my son's brain to the lab and they sliced it, they stained it, and they looked at it underneath the microscope. And they wanted to get the results before they sealed my son back up. I mean, how important of a job is that? Those brain surgeons, probably the smartest people in the world, were waiting for some lab techs, right? Equally as important, to tell them whether or not that tissue was a thumbs up or a thumbs down. What do you think about that? So some of you might say, I want to be a lab tech. You know, I want to be in that area where I'm getting tissue, whether it's a biopsy or if it's maybe it's a fluid sample. I want to be the one that's doing the analyzing. But what's amazing, I think, is that when we look at histology, how much of it is automated. So I have a little video that talks about the lab. We'll watch this, give you an idea.
Pathology and laboratory medicine is directly involved in patient care.
We're dealing with a lot of disease and cancer, and we know that the patients are relying on everything that we do to do it right.
A routine day, we could receive up to 500 specimens, and then we're going to put out between 3,000 and 5,000 slides every day.
When your doctor tells you that they're sending your blood work or specimen to the lab is really a huge organization in the Department of Pathology and Lab Medicine.
My name is Gloria. I'm going to get a few samples of blood from you.
The face of the laboratory are phlebotomists. They meet you in the lab, they draw your blood, and then process those samples, and then package them up and ship them up to the main laboratory. It's a fully automated laboratory where specimens are taken into the lab. Those samples have a label, they're barcoded, and they're placed on the automated track system. And once they go on the automated track system, those tubes of blood are then automatically put into the appropriate instrument, where then the appropriate analysis that was ordered is performed. It'll have several more analyses until it finally gets to the end of the road, where it then goes off into refrigeration storage. So that's kind of the life of a sample in the automated laboratory. In laboratory medicine, we have approximately 10 different laboratories. We're standing in the immunology laboratory, but also within this section is the HLA lab, always known as the tissue typing laboratory, which supports all of the transplant programs here at Penn. We have something called a flow cytometry laboratory. Down the hallway, we have a endocrinology laboratory. We have a large molecular diagnostic lab. We have a toxicology laboratory. We have a cytogenetics laboratory that looks at cytogenetic abnormalities, again, for various cancers. And we have a microbiology laboratory. Not everything is done in an automated fashion. When we get certain samples that have to be run on instruments that are not on the track, or there are very tiny samples, like from babies or from people that we couldn't get a sufficient amount of blood. Those samples are handled in a manual fashion. We do over 6 million tests per year in the clinical laboratories. And so that's a huge number of tests. And in fact, this is that the vast majority of routine laboratory tests in the core lab take about 30 to 45 minutes to complete. So we have an extremely large team. It's over 400 employees in the department.
Surgical 10131. This specimen is a heart transplant biopsy. Surgical pathology is really about the diagnosis of what's going on within the patient. It's about the examination of the tissue, anything being removed from a surgery, whether it be cancer, normal, disease. We look at it both grossly with our eyes and then also take pieces of it to look under the microscope to be able to accurately identify what's going on. The samples come up if it's coming from the OR and they are looking for a quick diagnosis. Once we confirm that everything, we will do a frozen examination of the tissue, which means that we take a small piece of tissue, we freeze it in a cryostat, and we cut 4 micron sections of that tissue and put it onto a slide. Once we've stained it and actually do a diagnosis within 20 minutes of receiving the tissue, and that allows the surgeon to really focus their direction of the surgery from that point on to what's going on within it.
So take a look at those slides. Those are the exact slides that we're looking at in lab. And they've been sliced, they have been stained, and we get to observe them, you know? That's why some slides look orange or blue, because there's different stains. So it's really cool, I think, and now maybe you have an understanding of why we spend, you know, some time talking about the histology of tissues, because it really is an important component of anatomy. Take a look at this slide. This will help you maybe get an appreciation of what the slide looks like and how it's sliced. You can see, for example, if we would look at a sweat gland underneath the microscope, a lot of students say, well, wait a minute, the sweat gland is the tube. Why does it look like this, these circles underneath the microscope? Because this tube goes in and out of different planes and it's sliced. And so it ends up looking like this. Or when you look at a tube like this, you can have 3 slides that look completely different. But you have to kind of visualize how was it sliced to get that. So slicing is an important component of histology, no doubt about it. You can see that some slices produce slides that maybe look like this, or even somewhat of an oval shape. So you can have different types of sections. Now, the only time that we will slice something is in 152. So that would be your next semester, fall semester. And you'll be slicing like the heart and the kidneys. You'll be doing some maybe different oblique sectioning. But for 151, the only time you'll see these words probably are really tiny on the slides, which I don't think many of you really have paid attention to. But when you grab a slide to look at it, it's going to say testes, CS, cross section. You know, gives you an idea of how they sliced it. Okay, so you know I'm into tables. So let's start a table for this section. And what we're going to say is important for this table is the type of tissue. And there's 4 of them. And your job is to tell me some of the characteristics maybe their function, their location, and of course an example. Now I think some of you have already started to do this with the pictures of the slides on your phone. Remember, I think even someone, I can't remember which lab it was, said, oh, I'll make a PowerPoint. I'll put a picture on a PowerPoint slide and put most of this information down so you can study it for lab next week. So the good thing is that you've already started. What we're going to do today is we're going to talk about epithelium first. Then we'll get into connective tissue. Then we'll talk about muscle. And we'll end with nervous. So those are your 4 tissue types. So when we think of the organization or hierarchy, we started out with atoms, molecules. We got into cells. We got into organelles. Today, we talk about tissues, which are how cells are grouped. On Tuesday of next week, we get to talk about an organ, which means they have many of these tissues working together to form or do one function. Okay, so that's good. Now you have your table. So your job, like last class, is to play the game and fill it in. You can do it. So let's start with some characteristics of epithelium. First thing that I would say, you know, I don't know if you can write all this down now, but you can say that the cells are tightly packed together. So cells are tightly packed together. which provides the cells or the tissue with its main function of protection. So epithelial cells are found protecting things. So let's take a look at this. Our body has thousands of tubes. Thousands of tubes. You could say the urethra, the intestines, the stomach, the esophagus, blood vessels, tubes, and they're everywhere. And if we cut any one of those tubes like this, a cross section, it's going to result in something that looks like this. It's like saying, hey, here's the garden hose that's outside. If I point that garden hose at you, it looks like this. You with me? So we're going to say that this hollow opening is called the lumen. And you will always find epithelium cells tightly packed together in two places. One, look, lining the lumen at this star, and outside protecting. Take any slide that has a tube in lab this semester or next, and impress your lab instructor next semester and say, whoa, we're looking at the intestines. I see epithelial cells lining the lumen. It doesn't matter. This is a 100% guarantee, because we have cells tightly packed together and they do a good job of protecting. Another thing you can see is that when we have a layer of cells that are either exposed to an open space like the lumen or an open space around, it always seems to be that one side of the epithelial layer is exposed to nothing, freeness. Like the lumen, we're out here, nothing. So another way of thinking about it. Third characteristic is that they are avascular, which means no blood vessels. Avascular. So they do not have blood rushing to the cells. They receive their nutrients by diffusion. Oh yeah. And they are not free floating, they are resting on a basement membrane. They're attached. Those are all characteristics. Their main function is to protect. But you're going to see in a few minutes that there's some other functions that you can add to your table. Another component of epithelium is that they come in a number of different shapes. For example, one shape is that the cells are squashed like pancakes, so we call them squamous. Or they're cubed like a dice, or they're column-like. So we have squamous, we have cuboidal, and we have columnar epithelium. The cool thing about their shape, this is what anatomy and physiology means, is that usually the shape kind of relates to their function. So if we have a cell, look, that's really thin, it's probably designed for quick and easy diffusion. It's something that can pass through it really quickly. It's like thin, just paper. So we would find squamous epithelium in your lungs, where you exchange oxygen, a gas, and carbon dioxide. Cuboidal cells are mainly involved with filtration. And columnar cells are involved with secretion sometimes and absorption. So all of those functions you can fit into that column in your table. There's a lot of functions. So let's go over this again. We have three different shapes, but now we have to throw in two more words. And the words are either simple or stratified. Simple means that there's just one single layer, like simple squamous. Stratified means there's more than one layer, like stratified squamous, stratified columnar. And now some of you are remembering that you had that slide, stratified or simple or whatever, and it makes sense now maybe. So in your book, there are some diagrams that look like this, and you do not have to study any of this. You just have to know only the tissue types that we talk about today in class. Just the ones that we talk about in lecture. So that means in lab, you have to know way more than you do for a lecture. So I will give you a big hint on which ones you need to know. Let's start out with this one. This is definitely on the list. The good news is that you had to see this and identify this in lab. Notice the name. It says that it is pseudo-stratified, falsely stratified. Remember, stratified means more than one layer. So this type of tissue says that it looks like more than one, but I'm faking you out. I am falsely stratified. So all of this crap right here, look at this. I mean, this looks like many layers. It's just one. You can also see that in this case, this type of epithelial cells has a basement membrane. It has a free surface, and there's even cilia on the top. You might remember that from lab. Here's the picture that we see from lab. Again, you can see the basement membrane. They're all attached. You can see the white space up on top and cells that are tightly packed together. These white big openings are goblet cells, and we'll talk about those eventually, but those are glands that help produce mucus. This is one that I want you to know. This is a transitional epithelium, definitely stratified. So I think I'm going to stand over here if it's okay, because I feel cool air coming on my head. So this is definitely more than one layer, but look at the characteristics. Attached to a basement membrane, has a free open space. And we find this in places like the bladder. So the bladder is constantly changing shape. Some of you are saying, man, I gotta go, right? I drank a bunch of coffee or a bunch of caffeine. So your bladder is expanding, it's not ripping, it's stretching. So what accommodates that stretch is the fact that these cells can reproduce like crazy. It's pretty sweet. Here's a picture that it may look something like this on your phone from lab. So let me stop right here to give you a big hint for exam 2. You know there will be a table, right? One we drew on the board. So you're good with that? And if any of you missed anything from the table on the first test, you're going to say that can't happen with test 2. I'm also going to show you some slides. So that's new. The first probably 10 questions of exam 2, I'm going to turn off the lights. And I'm going to show you some slides and ask you some questions about what we see. So the only slides that I'm going to show you are slides that I have shown you in class. So maybe it would be a good idea to take out your phone and take a picture of these so that you're not shocked or surprised when it comes testimony. And if anyone is not here today taking an exam, taking this class, if you're taking notes for them, you're a really nice person. Share with them these pictures. So there's pseudostratified. Good. Everybody okay? Then we said there's transitional. That's good. Okay.
Can you go back?
And that's it. Those are the only two. Those are the two epithelial cells that will be on the test. Now there's a lot more that were on the lab test. But for lecture, that's it.
Go to the first one again.
Oh gosh,
My camera's never ready.
you know what? You're starting to sound like me. My kids would say, Dad, you are the slowest phone operator in the world.
Well, that's because it's always pointed towards me, so I have to flip it.
Oh,
Yeah.
oh, I get it.
Yeah, so it
I
takes
like
me-
that. You're into the selfies.
Exactly. Thank you.
Guess how many selfies I've taken in my life?
Probably one.
0. I've never taken a selfie, never will. let me go off topic for a second here. So on July 7th, this year, my son's getting married in Cleveland. And last night, I went to this place to get fitted for my suit. And since we're a family, I'm gonna say it. It's my first suit in my life. Yeah, I'm not a suit guy. And I go into this place.
Not even for your wedding?
Well, I think I wear a tux. So I went into this place and they said to me, oh, we're not doing pleats. I didn't know that was a thing. Oh, your shirt is way too baggy. Oh. So I felt like, I was way out of my element. But I got it. My wife was there. She picked the color. So I think I'm good, but that was not a good experience.
You're gonna look so sharp.
Oh, I will look sharp. All right, so let's move on to connective tissue. Connective tissue is different from epithelium because we have cells that are not tightly packed together. That's the number one characteristic. Cells that are not tightly packed together. So instead of having cells that are crammed up against each other, we have a lot of non-living stuff in between the cells. Write this word down. Ground substance. That's the official term for the non-living stuff in between cells. Ground substance. Now in parentheses, and put a big star by this, the best example, in my opinion, of connective tissue is blood. Everybody hear this. My idea of connective tissue is blood. Because when you think of blood, you have red blood cells and white blood cells. Listen, platelets, these are all living cells, suspended in non-living plasma. Are they attached to a big? No, they're floating. It's the best example. So on the exam, here we go. This is like the third question I'm giving you that's on test 2. When I ask you, everybody hear this, when I ask you why is blood a great example of connective tissue, if anyone in this room writes down this answer, because it connects the body, I will put minus 50 if it's only worth 5 points. Every year I get, oh, it connects the body. No. It's an example of connective tissue because there's a lot of non-living ground substance in between the cells. Plasma. You better not be the one that says it connects the body. I might even have to, no, I'll be next. All right. So connective tissue, ground substance. There's so many functions that this slide doesn't even give it justice. It's all on your lecture outline. It connects, it supports, it provides energy, it allows for movement. So connective tissue, there's so many examples. Let's go and show you some. This is one that, do you need to take a picture of this? I think all of you are sick of looking at the blood slide and laugh, but go ahead if you want to take a picture of that. Blood. Blood, right? The best example of connective tissue. Here you see red blood cells. Look at all these. These big purple things are white blood cells. These little specks are platelets. And all of this white space, what if I showed you this slide in 2 weeks or whenever we have our next fest, and I point to this white space right here, and I ask you, tell me the significance of this white space. And you'd say, oh, it's the ground substance, it's plasma, it's non-living. It's one of the main characteristics of connective tissue. You do not have to write down anything from this slide. You do not have to study this slide. That's good. But you can see that there are some examples, and most of these examples will be discussed next semester. So, all of these, you may hear about fibroblasts, macrophages. Again, I'm not going to have any questions on test 2 about this slide, none. But these are some examples that you will hear about next semester. This slide is important, so I want you to put stars by these. When we think of connective tissue, there are some connective tissue fibers that are usually found in places that provide strength and support, like collagen. Collagen is a protein. Collagen, you think of found in skin, gives our skin support. Collagen is found in joints. It's tough. So when we think of connective tissue, sometimes it's supplied or supported with collagen. In addition to collagen, we have another protein called reticular fibers. These are kind of like the framework or the skeletal system of organs. So this is a type of connective tissue fiber. And the third one is probably the coolest one. It's called elastin, or elastic fibers. This is what allows stretching. So if I fast forward to next Tuesday's lecture, one of the best lectures of the session, I think, skin, we're going to talk about wrinkling. What happens when your skin wrinkles? Ready, everybody? You break down collagen that provides strength in your skin, and you break down elastic or elastin fibers. And the result is that your skin sags or wrinkles. We'll talk all about that on Tuesday. In addition to the fibers, the organization of connective tissue is somewhat important. You can see that loose connective tissue means that the cells are not in any type of order. In fact, there's a ton of ground substance in between. And there's some examples, and I'll show you a few of these. And then there's what we call dense connective tissue. And the only difference between this type of connective tissue is that it seems to be more collagen-based. Collagen-based. So loose is kind of a support tissue, but dense means it's probably involved with strength. So an example of connective tissue would be a tendon or a ligament. Oh, dense connective tissue, no doubt. Some of you have this on your phone from lab. It's called loose areolar connective tissue. I know you have a picture of this because I saw it in the lab. And look at the arrangement of these fibers, these collagen and elastic fibers. They're all kind of random. It's loose. But what I want you to, take a picture of this, by the way. What I want you to write down in your notes is that this is really the definition of the basement membrane of epithelium. So when we say connective tissue provides support, a great example is that it supports epithelium. So if you go back and look at some of your epithelial slides from lab, and you say, how are they attached? You might see stuff that looks like this. When you look at reticular fibers, go ahead and take a picture of this. This is an example of the framework of different organs. I don't think you have this slide in your pictures from lab. So this might be a new one. So you'll have to recognize this one for the lecture test. And then the last type of tissue, well, it's somewhat related, is adipose tissue. Look at this. I think, now I can remember for a fact that Rick, you had this one, right? Did you have this in lab? Who, Taylor? Okay. So adipose kind of looks like empty, missing cells. And if you squint, you can see that the nuclei are shoved to the edges of all of these cells. That's why they look empty. Yeah, Rob?
So for the test, are we gonna just need to identify them, or are we gonna have to write things about them?
I think for the lecture test, it's going to be mainly identification.
Just, you're gonna show us like a picture, we
Yeah.
just have to identify it? Okay.
Yeah.
Okay.
Now for lab, if this is something that you had on your phone, you have to know a little more detail.
Okay.
Yeah. One of the things about fat cells that I think is interesting is that a lot of us, including me, are trying to lose fat, maybe drop a few pounds. And when we think about how many fat cells that we have in our body, has a lot to do with genetics. So we are not all born with the same number of fat cells. That's crazy. But what we do to our fat cells in terms of, listen, our diet and our exercise, and for some of us, it's also influenced by hormones, is that it can cause these cells to become gigantic. They have this weird ability to like balloon up. So if you eat a lot and you don't exercise, they're gonna balloon up and you will balloon up. If you exercise or burn more calories than you eat, you're going to shrink the cells and you will shrink, right? But they're always ready to go back and forth, you know? So the only way to really, I guess, lose weight, but still not permanently, is to suck them out. You've heard of liposuction. And when you suck out these cells, it just gives, listen, it gives more space for the ones that are still there. So you might say, oh, that person looks really good. How did they do it? Well, they had liposuction. But then in like 5 years, they're back to the same because those cells that are still remaining are saying, whoa, all this extra space. You know? Fat cells are tough. The other good thing about fat is that it's a great insulator, it's a great protector, and it's a great cushion. So if anyone in this room thinks, I need to lose all my fat, that would be unbelievably wrong and unbelievably unhealthy. Now take a look at this. This is an example. Take a picture of this. This is an example of connective tissue that's very organized. So we say it's regular, not irregular. And this is nothing but kind of ribbons of collagen. This is what a tendon looks like. So notice it's not random, it looks like it's dispersed, it's very organized. This one is irregular, but it's dense, which means there's lots of collagen. And you find this in many places, including, ready, for those of you who had lab on Tuesday, the dermis of the skin. My wife has family history of breast cancer. Her grandmother died of breast cancer. Her mom had breast cancer. My wife is very proactive with her mammograms. And every year when my wife gets her mammogram results sent to us, it says literally this: your breast tissue is very dense. And the first time my wife got that letter that says your breast tissue is dense, she had no idea what it was. Like, what does that mean, dense? So I tried to do an anatomy minute with her and say, this is what it looks like. I mean, this is like a jungle. How do you find abnormalities in a jungle? Because if you are smaller or muscular in terms of your chests, if you're a female, versus, look, a larger woman on top, which is mostly fat, this is much easier to find abnormalities than something that looks like this. So every year my wife has to go back for a second scan. Yeah, it's like routine now. So that's what I think of when I think of dense, irregular.
Is it finding the dermis or the hypodermis?
It's in the dermis, not hypo. Yeah. Another example of connective tissue is one of the weird ones. One of the characteristics that you can include into your table for connective tissue is that not only is there a lot of ground substance, but connective tissue, for the most part, is very vascular, something that's different from epithelium. Vascular means blood supply. The one that is not, kind of the rebel, is cartilage. Cartilage is avascular. So listen to this story, put a star by this, maybe a wink face, however you draw that. But if I would ask you on the exam, if you had a choice of breaking a bone or tearing cartilage, and you want to get back to normalcy as fast as possible, you would definitely say break a bone. What? Because bone is unbelievably vascular. Bone is full of blood. Cartilage, avascular. It heals by diffusion. Oh man, slow and steady. So if you tear cartilage in your shoulder, whether it's your labrum, or if you tear cartilage in your knee, and it's a long rehab. Bone, as I said, is another example of connective tissue, and it is unbelievably vascular. You guys have a picture of this already on your phone. It's one of the most unusual, easy to identify histology slides in the world. And all of these black spots right here represent canals full of blood. So if you break a bone, you will heal faster than cartilage, because cartilage does not have blood supply. All right, last example of connective tissue is the one we started with. So everybody should be good with blood, right? We're all good. We've seen this 1,000 times. Let's move into nervous tissue. I guess we'll do muscle last. Nervous tissue is unusual in that its characteristic, right, is that the cells typically do not divide by mitosis. Typically. Now, it doesn't mean all, but if someone has a brain issue like a stroke, most cases says that it's going to be hard to recover or get back to 100% recovery. If someone has a spinal cord injury, probably you're not going to get back to full. Maybe you will, but probably not. If you're a big football fan and you're a Bengal fan and a Steeler hater, you should get extra credit on the next test if that's true for you. But if you are a Steeler fan, you remember Ryan Shazier, who got drilled by a Bengal player and was paralyzed, and they just had him like on Twitter like a week ago at a wedding reception, kind of like trying to dance. So he's probably getting incredible therapy. And so there's always an exception. But in general, cells from the nervous tissue do not like to undergo mitosis. All right. In terms of nerve tissue, the main structure that we're going to be looking at is this structure called a neuron. Its location is in the brain and spinal cord. You have this, of course, on your phone from lab. So hopefully you remember that. Neurons are unusual in that they are the only cells that secrete something, release something. So when we think of neurotransmitters, big topic down the road for this class, those are chemicals like acetylcholine, maybe you've heard of that, or epinephrine, or serotonin, or melatonin, something like that. Those are neurotransmitters that are released by these neurons. We're going to have an entire exam dealing with nervous tissue. So today it's just kind of introducing them. Last tissue type, muscle. So big characteristic of muscle is that it's tissue that can lengthen and contract. It's involved with movement. So there are three examples. There's muscle that's involved with pumping blood. That's called cardiac muscle. There's muscle that you're using right now to move your hand. Muscle that you can control. That's called skeletal muscle. And then there's muscle like inside of you that you have no control over, like your stomach and things like that. That's called smooth muscle. I hope that you have 3 pictures of this on your phone from lab. But let me show you some examples. If you see a slide that looks like this is worthy of a picture. You say, whoa, I see stripes. And look at this, I see a cell with more than one nucleus. You're going to say skeletal muscle. So those are characteristics of skeletal muscle. There are stripes, which we'll talk about later. And we have a multinucleated cell. We only have a few of those in our body. A cell with more than one nucleus. And when I'm talking about skeletal muscle right now, I'm having a hard time not looking at Vince's arms. Vince, dude, I had no idea that you were that jacked. Vince, my gosh, look at those arms. cardiac muscle. You warned me. Okay. I take a fall. So here we have cardiac muscle, and notice that it is also striped. Well, what I want you to write down here in your notes and put a star by is that cardiac muscle has these junctions called intercalated discs. Intercalated discs. We'll talk more about those, but they're only found in cardiac muscle. The last type of muscle is the one that's found in places like the stomach. Notice there's no stripes. They're thick in the middle, and they're tapered at the ends. It's called smooth muscle. You could also call it involuntary muscle because we have no control over it. So, 3 types of muscle: skeletal, cardiac, and smooth. All right. So that's our overview of histology. Hopefully that brings back some memories from lab. So in the last 15 minutes, we're going to talk about a few other things, and we'll call it a day. The first thing that we're going to talk about is ways that some cells can communicate with one another, or how they are interacting with one another. And we have 3 types of junctions. It's hard to see, so write these down. We have tight junctions. We have something called a desmosome. And then we have a gap junction. All 3 of those will be on the test. Tight junction, desmosome, and gap junction. So let me talk about kind of some analogies. I would say that a tight junction is kind of like a zipper. Like a zipper. It makes sure that that one cell is tightly zipped or attached to its neighbor, so nothing can squeeze in between them. Remember the definition of epithelial cells? Cells tightly packed together. They have lots of tight junctions. A desmosome is like a snap or a button. And think of a desmosome as kind of like an anchor. It keeps the cell in one location. So if I would ask you, this would be a good question. What keeps the epithelium attached to the basement membrane? Probably a lot of desmosomes. But then the last type would be a great example of an intercalated disc. It's a gap junction. It allows communication from one cell to another. Next semester in the fall, or if you wait a semester and take me in the spring, and we'll talk about gap junctions, and we'll say, hey, remember that back in 151? Yeah, I don't think we remember that. Okay, let's talk about some other things that we find in between cells. Here we find some glands. And we can put the glands into 2 major categories. We can say they are exocrine glands or they are endocrine glands. So know the difference. Give me an example. So let's do endocrine first. If a gland is considered endo, then it's putting something into the bloodstream. So all hormones that are released by your brain and other organs are dumped directly into your bloodstream. If you have a hormone problem, listen, you go to an endocrinologist. Makes sense. An exocrine gland is something that leaks something out of something. Think of sweat as being a great product of an exocrine gland. Tears from your eyes. If you're a breastfeeding mom, milk, right? Those are all exocrine products. So no one in this room is going to say, oh, that's hard. Endo is into the bloodstream. Exo is exiting out of the cells. Some cells are mixed, which means that they can do both. Some cells only have one function. Just remember what an endo and an exocrine gland is. You do not need to know any of this. This can be completely crossed out on your lecture outline. But if you're interested in what the exocrine gland looks like, if we sliced it, it has a bunch of tubes that lead to the outside. None of this, 0%, will be on the test. None of this will be on the test, 0%. None of this will be on the test. You can see that some exocrine glands have multiple, what we call multiple branched ducts. Yeah, whatever. So that's not that important. These are important. Put stars by these. When we look at exocrine glands, we can say they are serous. That's important. That will be on the test. Or they are mucus. If it is a serous exocrine solution, it's watery. So think of sweat and tears as being a great example of a serous gland production. Mucus is like snot. It's going to be thick, sticky, gross. So we have mucus in lots of places. Did you know that in some cases we have places where we have both, like our mouth? Think about this. If you are really hydrated right now, you're not even thinking right now about the consistency of your spit. It's probably so watery, you're not even thinking about it. But man, if you are really thirsty, your mouth is starting to get kind of sticky and dry and disgusting. It means that it's low in serous, but it's high in mucus. Some people say, oh, man, I've got cotton mouth. Oh, that's disgusting, right? Drink some water. That's what you say. All right. Take a picture of this one. Yes. I didn't hear you. You definitely need to know serous. You definitely need to know mucus. An example of each, 100%.
If like you ask which is more serious and which one is more mucus.
I would ask you what is serous and what is
I was
mucus.
just like, you would ask.
Yeah. Take a picture of this. This is a good one because this is going to be involved in our lecture on Tuesday. This is relating to a gland in our skin called a sebaceous gland. If you had lab on Tuesday, you already know about this. But a sebaceous gland is one that produces oil that lubricates your skin. And you don't have to look at the arrows or anything, but that's the way it kind of releases its fluid out of something. So it's called a holocrine gland. It's a subtype of an exocrine gland. And the only reason why that I want you to notice this one is because we're going to see it in lecture on Tuesday. Would you say it, Amanda?
How do you spell state? What is it?
Sebaceous?
Sebaceous?
Yeah, S-E-B.
S-E-B.
Aceous.
ACEOUS.
Yeah.
Thank you.
Yeah. All right, then in lab on Tuesday, we talked about sweat glands. We talked about some disgusting characteristics of sweat, like how some sweat glands produce fluid that stinks and some produce fluid that doesn't stink. So notice the sweat gland structure and underline the word merocrine and apocrine. Merocrine produces the sweat that does not smell. It also is involved with tears and other juices. Merocrine. So like forehead sweat, back of the neck sweat. But apocrine, remember what I said on Tuesday, how to remember this? Ape, like going into the ape exhibit on an August day, where it's 100 degrees. Oh my gosh, like the smell. So apocrine produces a sweat that smells. We'll learn about why it smells on Tuesday. Now, this, what'd you say?
What would that sweat be then, like people's,
What kind of sweat?
the funky sweat?
Apocrine.
Yeah, the apricot sweat.
Yeah.
Armpit.
Oh, armpits,
Okay.
crotch.
I was gonna say like.
Yeah, let's not talk about that.
Okay. Never mind.
So when I teach 152, I tell my students, I say, listen, I had a really bad anatomy teacher at UC back in the day. He when he taught reproduction, he taught about things that were so disgustingly, like, why do we need to know this, you know? It was like he enjoyed talking about weird things. So I don't do that when I talk about sex. And I don't talk about pooping when I do digestion. So I'm not gonna go to the crotch area.
Oh, no, you're fine.
This slide is probably the coolest slide of the day because it organizes everything that we've talked about, all the tissues, into our first organ on Tuesday, skin. Look, here you have muscle. Here you have loose areolar, basement membrane. Here you have epithelium. Here you have glands. And there might even be a nerve or something inside there. So that's the definition of an organ, where you have tissues coming together, teamwork, providing a function. All right, this is something that you will have on the lab test. Remember, you had to identify cavities and some types of membranes. We talked about the pleural cavity, synovial cavities, serous cavities. So all you see here is that when we look at organization, as we move from cells and tissues into organs, that many times we have membranes that surround it. So just remember that there are membranes. That's kind of our next step before we get into tissues. Last topic of the day, we're doing great. These are terms that are really, really important. So I want you to put stars by all three of these. Hyperplasia, hypertrophy. So from last test, we said that hypertonic meant high amount of solutes. Hyper always means excess. If we say something is undergoing hyperplasia, we're saying that the cells are dividing like crazy. Maybe you say you're going through puberty. Or maybe you say you're talking about your fetus in your wife's uterus. There's a lot of hyperplasia. That's normal. Normal accelerated growth. Hypertrophy is something where you cause one cell to become much bigger than it normally is. So examples of hypertrophy, already we've talked about this, right? Are fat cells. Adipose cells have the ability to get gigantic, and then you become gigantic. Or think about Vince's arms right now. When you look at Vince's arms, you say, oh my gosh, those are unbelievable. How does Vince's arms get so big? Does he work out? Does he take like illegal substances? Vince, you better know. So how come his arms are like three times the size of mine? Because his skeletal muscle cells, ready, are undergoing hypertrophy. That's a great thing to remember. Because when someone bodybuilds and has really big muscles, most people think, whoa, you're making more muscles by lifting. You're making more. You have way more. Vince has way more than me. No, he doesn't. His muscles are just way bigger than mine. Hypertrophy. Okay. Neoplasia is something you never want to hear about, right? Neoplasia means excessive growth with the formation of a tumor. Neoplasia. Two other terms up here that I want you to circle: differentiation and metaplasia. Oh, these are really important. 1,000,000% on the time. Differentiation usually is involved with development. When you say my fetus or my baby, whatever you want to call what's growing inside of you, is developing, you're saying that the cells are changing into something else. Maybe you think about back to the world of stem cells. We'll talk more about stem cells in a minute. Metaplasia, this is unusual. Metaplasia means that you have one tissue type changing into another. And that really doesn't happen very often. We might have metaplasia in smaller levels. Look, like this shape of epithelium changing. For example, I hope no one in here smokes. But if you are a smoker, you may change the shape of the epithelium inside of your trachea. you may change them from being pseudostratified columnar with cilia on them to squamous. Ah, that's not good. No cilia? You can't move all that crap up. And all of a sudden now you're coughing like a madman, right? So there's examples of metaplasia, but they're few and far between. Okay, last slide of the day deals with a topic that some of you look at and you say, oh, I can't wait to talk about this. And then there's some of you who will say, oh, let's stop. I'm against this. It's against my religion. It's against my ethics, morals. Stop talking about this. So I want to kind of shed some light, and I want you to underline the word plasticity in your notes. To say that cells are plastic means they have the ability to change. They have the ability to change. If I would arrange the stem cells from most plastic to least plastic, that's what I'm doing up here. So the king and queen of all stem cells would be a stem cell that can become anything. Oh man. So people with Parkinson's, people with spinal cord injuries, people with Alzheimer's, people are saying, man, just give it a shot. Let's see if we can do it. You know, there's so much potential. Maybe it could be healed if we used a totipotent stem cell. Or pluripotent. Pluripotent cannot become anything, but pluri can become, ready? Many things. Multi can become a few, and uni can become one. So, maybe you should write this down next to it. Any, many, few, one. So, I'm going to say that in the United States that it's very impossible to retrieve totipotent stem cells because this is usually from like embryonic tissue. It's just not something that the United States will fly at this point in the game. But if you travel to like Mexico or places in Europe, you could probably get totipotent stem cells. Again, if you're a big football fan, you follow the Colts a few years ago. Peyton Manning was the quarterback, and he had some spinal cord injury. I don't know if you knew about this upper neck stuff. And so he went to Europe and got stem cell therapy. He came back. Colts said, I don't think so. Broncos said, yeah, I'll take you. And he won 2 Super Bowls with them because he had stem cell treatment that he couldn't get in the United States. Whoa.
Just 1 Super Bowl.
Oh, was it 1 Super Bowl?
He went to 2.
He went to 2. Well,
Had a hell of a defense.
that's still good. It's still good. I think they got their money's worth. If you look down here at the bottom, this is, in fact, these right here, these are considered adult stem cells. And this is the reason why I kind of wanted to talk about stem cells and maybe change your mind a little bit. Because I think a lot of you in this room probably heard of bone marrow transplants. Maybe you even signed up because of a friend who had leukemia and you wanted to see if you were a match. Because I think any one of us in this room would donate our bone marrow to any one of our friends or family members to save their life without even thinking about it. But you're donating your stem cells. What? You're donating blood stem cells. And no one thinks anything about that because it's adult to an adult.
Isn't it painful?
Oh, it's really painful. Yes.
But it's still really important that you do it because it's like a 1 in 7,000
Yeah.
person match.
Is there a match?
If you're not
One of
signed,
my
if-
friends in middle school, he was a
Yeah.
match for his sister.
If anybody's not signed up, totally do it. That's my
Yeah.
soapbox for the.
Yeah, so when we sign up and maybe be a match and donate, we're saying yes. But it's a stem cell, and so that's the thing. Not all stem cells are unethical. Some stem cells are done every day. And it's my belief, here's my prediction. It's not, don't write this down, it won't be on the thing. It's my belief that I believe that we will be able to trick or figure out how to convince our adult stem cells to go back in time to become maybe pluripotent stem cells or even totipotent. So someday, I think we're gonna see, and I'm not crazy, I think we're gonna see cells and tissues and maybe organs being rejuvenated from our own body cells. So this will eliminate, I think, the need and the demand for like organs for transplants. You drive down the street and there's yard signs everywhere saying donate a kidney or please somebody needs a kidney. But maybe, you know, in 2 lifetimes from now, your great-grandchildren will be able to grow their own. I think that's getting close. They're doing that with mice already. All right, so that's it for today. If you have lab, we start at 7. If not, may the weekend begin.